My name is Drew Malone with Cloudera, and I'm a self-entitled developer and DevOps enthusiast with the internal tooling team. We'll go over a brief history of what brought us here, what brought us the need for Salt Cloud. Quick introduction, what is Salt Cloud? A little bit of a vocabulary lesson so we all understand what we're talking about. I'll give you a quick crash course, getting started, how to build providers, how to get yourself started, making VMs without having to go to your infrastructure's dashboard. Touch a little bit on dynamic configurations with the SaltMine, and hopefully we can show you a live demo of building a small web application. So the good news is, we have a bunch of developers cranking out features at a blazing pace. We're doing great. People love us. Your problem is you've got a bunch of developers cranking out features at a blazing pace. They need to be able to deploy, test, and push to production very quickly all of these features. And especially if we're developing web applications, we have to be able to stand them up very quickly and tear them down. So how did we get here? Well, in the beginning, there were the cloud commands. The OpenStack fans, like back in the day, we had the Yuka commands, Yuka run instances, or the Nova boot command. If we were lucky, we were able to fire off an AWS EC2 command. And then after a little bit of time, we started getting clever, and we slapped together a couple of shell scripts. Maybe read it out of a config file and fire off a bunch of boot commands at the same time. I can launch 5 VMs all at once. That's nice, but we can do better. So we'll touch on, so this is our cloud orchestration. We do our homework, we set up providers, and with just a little bit of work up front, we can fire off entire stacks with a single command on our cloud provider of choice. So what exactly is Salt Cloud? Salt's a component. Salt Cloud is a component of Salt that gives us tight cloud integration. We use Salt to command and control our minions, our data centers, our applications. Salt Cloud is to command and control your infrastructure cloud. We can also gives us the ability to give our minions custom grains, and I'll go over that in some of the configs later on, which is really handy for giving out roles like all of my database servers, all of my app servers. We can define all of those in advance before we've even deployed a single VM. So we'll get right to the details. Salt Cloud components build on each other. To get started, you have to put together a provider. And this describes the infrastructure provider like DigitalOcean or AWS or your own private cloud deployment. What account are you using to log into, what region, all the boring details that we have to give on a setup at least once. Next is the profiles, which an example profile is a half a gig CentOS 6 machine. So if you're familiar with OpenStack or even AWS, this is your combination of a flavor and a size. And then that's enough to get you started. If you have just that, you can start firing off commands and make yourself one instance at a time and make yourself your development machine. You can reach out and quickly delete the VM, whatever you need to. Once you want to take it one step further, though, is where we can start writing map files. And in short, a map file really is just a sum of profiles. They're nothing too complex, just like almost anything in Salt. So something like, give me 3 CentOS VMs. Or like the example that we're going to show in just a little bit, it'll be my web stack application, a Mongo cluster, a couple of Nodejs applications. So here's an example of a provider. This is the one we're using for DigitalOcean. The docs on SaltStack are very good about getting started with all of the supported infrastructure providers. So if your provider is not DigitalOcean, yours is going to look a little bit different. Your variables are going to be a little bit different. But the docs are very good about taking care of you. They'll show you exactly what you need to do. Just yesterday, I managed to, I tried out Linode for the first time. And I had, in 5 minutes, I glanced at the documentation. I was able to see, here's where you go to make yourself an API key. Here's what your profile should look like. And in under 5 minutes, I had a few VMs living out on Linode that I could command and control, do whatever I needed to. Also, feel free at any time, if there's questions or if something's not clear, feel free to jump in. So once we've built our provider, we begin writing profiles. Anyone who's written a salt state might notice they're all written in YAML. They're all very similar. This is a single profile. We can write any number of profiles we want. Again, it's boring details. Where does it live? What image am I using? What flavor? How do I log into it? So this is the one step further. This is where we can begin to describe full applications. For real estate reasons, I couldn't fit the entire map file on this slide, but we'll show it in a few minutes. This is where we can say my entire application, my Mongo cluster, my app farm, my reverse proxy, all of them in a single text file. And also we can see where, this is where we're handing out the roles. It's a little bit chatty, and I think I can even do better on this to make it a little less verbose. But if you follow it down, this is, you can set arbitrary minion configurations here, either in the profiles or in the map files when you're defining all of your profiles. So in this case, I have a custom grain. My app servers have a role for UI. My Mongo servers, they have a role for Mongo. I have an Nginx machine that has a role for rproxy, which comes in really handy when I have to start targeting them for automation or for ad hoc command line control. So the problem is these machines don't exist yet. They don't have IPs. They don't have host names. They don't have anything on them. But we need to write, for instance, our Nginx reverse proxy. We have to tell our Nginx server what the IPs are of all those machines if we're going to be able to write a valid configuration file. So how do we know that ahead of time when we're writing our automation? Salt Cloud and SaltMine go beautiful together. In fact, I don't think I can live without SaltMine when working on a cloud infrastructure with Salt Cloud. In the SaltMine, your minions will deliver data up to the master, and the master will hold on to that information. And you can send whatever you want to send. In this example, all we're doing is sending the IP address of that minion. And it's very easy to set. There's several places you can place it. My favorite is to just make a pillar file that every single minion gets, and it tells them, send the E0 IP address up to the Salt master. And what that gets you now is any minion in your deployment can reach back into the SaltMine and can target it, just like you can on the command line. Give me just the IP addresses of all the UI servers, all the app servers, or give me just the IP addresses of the Mongo machines. So this is, again, the flexibility and the power of something like Salt combined with a cloud infrastructure. And we'll notice the optional final parameter there. This is optional. The default targeting method for mine calls is your classic globbing, just star, UI star, or something like that. But since we have our custom grains, we can target them by grains, just how we are on the command line, which is why the last parameter we say expression form is grain. Target on that instead. So that's enough for the slides for now. We'll go over and see what this actually looks like in action. So here's the default location for map files in a Salt deployment. And this is the map file that we're going to deploy. We've got our app servers. We've got 2 of them, 3 of our Mongo machines, and finally our reverse proxy. Very easy to do. Salt Cloud, we give it a -cat for parallel so that we can spawn multiple threads. So we're not doing them sequentially, making one machine, waiting for it, and then making the second one. We can tell it, fire off a bunch of threads, come back when you're all done. -m is for map file. We can feed it our map file. And so what happens is Salt Cloud's going to reach out to our cloud provider, compare the map file with reality. Read in the map files. I don't see any machines up there by that name. They must not exist. I'm going to make these machines for you. Is that okay? You good with that? We'll tell it yes. So for the case of brevity, I'm not going to make you guys sit here and watch a bunch of machines spawn. So we're going to go with the cooking show method here. And we're going to switch over. This is what happens after all of these machines have been deployed. So what happens is Salt reaches out to your infrastructure, creates the machines for it. Once they come alive, it'll, using the details that you provided, it will SSH into that newly created machine and use Salt Bootstrap to bootstrap a minion onto it, configure it to point back to your master and turn on the minion service. So that all you have to do is fire a single Salt Cloud command and you've got a brand new minion you can command and control. It's worth noting that you can use the default Salt Cloud script, but in here, you can just as easily say so if you're in an isolated environment or for whatever reason the standard Bootstrap script isn't working for you, you can write your own, put it somewhere, and you can point Salt Cloud to this one. Salt also, yes?
For the networking,
Mm-hmm.
right now you use deployer, correct? But for the networking, does it have like a default? Can you put a default networking subnet?
You can. What you can and cannot do are all functions of who your infrastructure provider is, if that helps. So the IPv6 parameter might not be meaningful to something like Linode or to another provider. Because in fact, I think I had to disable this because I was having issues with the minion trying to reach back to the master in DigitalOcean, which is why I have this one in here. But there's a lot of custom configurations you can do, absolutely. In fact, is it on this one? There we are. So this is a configuration for an OpenStack deployment we have internally. And the way that we have it, we can tell it what OpenStack networks we want it to be on, for instance. And so these parameters are here because this is an OpenStack deployment, as opposed to what I had a second ago was on DigitalOcean. Does that kind of help a little bit? Yeah, thank you. And the last part, in this location, in a standard Salt deployment, Salt also ships with a good handful of different scripts. They encourage you to use the standard default script, but if you need some inspiration for getting started with a custom one, or if you just want to use one for a specific flavor, you can specify just the name. So if just yesterday I was playing around, I can say script rel6.shell, and that's it. Salt will automatically look in that path to look for a script by that name. Failing that, back in etc salt, in cloud.deploy is another directory that it will look into. So you can place your custom configuration scripts in here. So what we have now is our fleet of instances that we created with the Salt Cloud command, ready to do something. They're all blank CentOS boxes. You need to give them a bunch of instructions. So I don't want to spend too much time on the states. We can if we want to go that direction. But what we have here is our top file that just hands out, keys in on our custom grain for the role, tells all of the Mongo boxes, you need to install MongoDB. Tells all the reverse proxy servers, you need to install Nginx and configure it to point to our app farm. Our app servers, you need to install the application. And we're going to be building a Mongo replica set, so someone has to be the primary. I've cheated a little bit here and just kind of hard-coded it into the top file, But in your own deployment, you can do the same either via pillar or whatever choice you've made for handing out roles and identifying your machines. So what this looks like, now this should not take too long. This I don't mind making you all wait for a little bit. Yes?
Did you set your startup states to high state or SLS?
Could you repeat the question?
So you use the maps to deploy the instances,
Yes.
and they install applications on them based on the states you have, right?
Mm-hmm.
So since you showed the top file, did you do a startup state as high state?
So the question is, did we use the startup states config so that the new VMs, when they come alive, they'll instantly be configured? Is that the question?
So you can specify startup state
Right.
as either
Absolutely.
just the state you want to run, or you can do a high state.
Right.
In which case the top file will be relevant, right?
Correct.
Since you showed the top file, are you doing a high state when the VM comes up?
No, and that's only just for this demo because I'm taking explicit steps. But you're absolutely correct. The next step would be using that config so that when the VM comes alive, it immediately runs a high state and you don't have to do anything. Yes, you're absolutely right. So I've tweaked the master output to be a little bit less chatty, so we can actually read a little bit of what comes out. So deploying some of these machines, I found that specifically Mongo kind of starts to pitch a fit a little bit if it doesn't have an entry for itself inside etc hosts. So in this case, I decided just, you know what, everybody gets to talk to everybody else. And this is an example of using SaltMine to just manage etc hosts for everybody. In fact, while we're waiting for that, so this is our state file. We just add a block of text onto etc hosts. And there's more elegant ways of doing this. You can have, I believe it's a file block replace to have a more elegant contained version of managing this. But for simplicity, we've just done a file.append. So the actual guts of that, here's our Jinja templated config. So this is our mine call. When you're writing your Jinja template config files, you can call arbitrary salt functions. And just how you can call SaltMine commands on the command line, you can do them inside some sort of a Jinja template. So we're telling, I want everybody's IP addresses. And what that does, it comes back in a dictionary. Because we're in Salt, we're in Python. We get back a Python dictionary. So we now have our two variables, host and IP. And for each one of them, set an entry in there for etc hosts.
That last line,
Mm-hmm.
that last line in that line?
Oh, yes, this one?
Yeah.
Yes.
Does that replace the existing line?
No, that is, it's going to enter out a new line that's going to be local loopback, and then this is going to be the host name of the particular VM. So for instance,
It doesn't replace the existing one.
correct. And that's because we've chosen a file.append instead of like a file.managed or something more aggressive.
I got a question on the host file.
Yes.
The host.present that's already in the state files, is there a reason you didn't use that?
Probably user ignorance.
Sorry.
So there's a host.present function to manage etc hosts.
So like what he was calling out here for the 127,
Yeah.
having duplicate line entries or something like that, this will check it to see if it's already there. If it is, it'll
Nice.
use that line or
I'm making a mental note of that. That's a much more elegant solution than what I've done.
just ran across it about 2 weeks ago.
Nice. Yeah, I need to start reading the docs a little bit more. You turn around for 5 seconds and they've got a dozen new features. It's crazy.
That's why we're here.
Yes. So to show the output of just our etc hosts. So here's the contents of etc host for every minion's etc host file looks like this. So we've run our high state. It looks like everybody came back fine. Usually you glance, blue's fine, green's fine, red is you need to triage, but not seeing a whole lot of red here, so I think we're good. So if this actually worked, what we should have is a successfully deployed 3-tier web stack. I apologize. My business card says developer. I'm not a front-end guy. I'm the guy on the back end taking care of the infrastructure. Sorry. This is a simple Node.js app that's serving up a static web page. The web page has been rendered through a bunch of Jinja templating to, again, a bunch of SaltMine queries to say, give me all the information for the whole deployment. So here we have the app farm. We have all of our Mongo servers. So let's see if we've successfully built our replica set. We've turned on the REST interface. So we've got 3 members in our replica set, which is exactly what we asked for. So that's a brief explanation of deploying a system. The other part of this, I'm sorry, I should have shown you this beforehand. This is what we've just deployed, is our Mongo cluster and app farm. So we've got two machines in our app farm. Back to the good news, bad news. The good news is you guys are really popular and you're getting a ton of traffic. The bad news is you guys are really popular and you're getting a ton of traffic. You need more horsepower in your app farm. Okay, so how is this done? What I've done over here, here's our map file. I've extended this map file. Previously, we only had the 2 VMs. So I cheated, did a little bit of copy pasting, and so now we've added 3 more machines into this deployment that we've described in our map file. Just repeat the automation. Salt will reach out and see, these machines already exist. These guys, though, don't exist. I'm going to create them. It's not going to work out. And you tell it, sure, that's OK. Let's do that. You have to actually explicitly tell it, not just hit enter. And so this will go out. And basically, this is a repeat of what we've already seen. Deploy a machine. It comes back into the Salt master. If we were really elegant, we'd have already set the configuration to have it run a high state when it comes alive. And we would already be done. Automatically join the app farm, come alive, and we're good. The other part of this so if you want to be really aggressive with, say, your compute costs in AWS or wherever your infrastructure provider is, there's an option called Enable Hard Maps. What this is, the command that we gave, how we can say saltcloud-m some map file, we can say -- hard, and it is the inverse of what we just did with expanding our app farm. We can take our file, edit it, collapse it, reduce the number of app VMs that are in our app farm, rerun our command, and Salt will say, there's only 2 app VMs in my map file, but I'm seeing 5 out there on the cloud. I'm going to delete those extraneous 3. Is that OK? And we can automatically collapse our deployment as well.
What part of this would configure Nginx proxy for the additional machines or the removal of machines?
Good point. So this is where you would have to start building out a little more robust ecosystem involving something like Salt Reactor or something like that. As is, you would have to run another high state, at least on your Nginx box, so that you can update the configs. Something more elegant, which I've not done for this demo, but something more elegant is you have a reactor that responds to a new VM. And when that new VM runs, he'll either tell everybody to run a high state, or depending on if he can tell, say what role that VM has, he can say just the Nginx server, since it's just an app VM that came alive. So if you want it fully automatic, you would start setting up reactors to respond to the new VMs. So that's our quick walkthrough, a quick demo of crash course on Salt Cloud, rolling out a couple of machines, getting started. This was a little bit introductory. Yes?
You had a link up there to show you files?
Absolutely. So this is the end of the technical part. If there's any questions, or if anybody would like to walk through any of the automation, otherwise, you guys are free to go and call your loved ones and get a cup of coffee. Yes?
It seems that the way of specifying the map is pretty well closed. Is it being compacted?
So the question is, the map files are very verbose. They're very redundant. And the answer is, I'm nearly certain there is a more compact way. I know that there is when you're writing salt states, there's a use parameter, so that you can just say, all of the configs that were specified in this other profile, use them too. I'll override them if I have to. I believe there is that option for the map files. Sadly, I haven't done the research in that, but yes, there are more compact ways of writing map files. Yes?
Have you had to encounter a scenario where, say like when setting up a type of cluster, it gets bootstrapped in one state before it becomes clustered, and then it needs to cluster itself after the fact, and how you would handle that sort of situation?
Could you maybe repeat the question, or a few more details?
I'll give an example. Like when you bring up a MongoDB cluster, the configuration of the first node starts in like a standard MongoDB Cloudera node. Then, after you bring up your second node is pointed back to your first node, and your first node is pointed back to your second node. So the bootstrap, the initial state when it's brought up, is different from its sort of long-term state once it's been clustered. So do you have any suggestions or ideas on how to differentiate that situation?
Sure. So the question is, when new machines come alive to join the cluster, they're basically in a different state, and what they need to do in order to join an existing cluster is going to be different than what they need to do when someone else joins. So we can't just write one set of idempotent instructions, and that just works for everything. I mean, it's great in a textbook situation, and we love doing it, but it's not always the case. I have, and what I would, in the future, what I'll start doing is probably using more of the orchestrate layer to say, don't make, say, the second node in the cluster. Don't even bother making the second one until the first one has been built and has been, everything has been installed and configured. Then the second one's ready to come online. Otherwise, honestly, what I do is I write a bunch of smaller state files. I build myself a pile of primitives, just a bunch of states. They do very small things. So then I can have a single state file that says maybe build and configure. And the contents of that state file is just a bunch of includes. I include the primitives that I need. So then I can say, when you first come alive, run this state file that's all my includes for an initial build. And I'll have another one that's for, say, join. And I'll pull in a different set of primitives for the different instruction sets that I need for that. It's not quite as elegant as saying just run high state and everything's great, but that's the best I've managed to do so far. Thanks. So if there's no more questions, you guys are free to go. Thanks for coming over. Hope you got a little something out of it. I'll be here for a little while longer if you have any other questions. Thanks for coming out.